Welcome to day 20 of our programming languages series. Today we will dive into the implementation of programming languages covering essential phases like lexical analysis, parsing, and code generation. We will also explore the differences between compilers and interpreters and learn how just-in-time compilation works. Let's start with lexical analysis, the first phase of language implementation. This step breaks down the source code into meaningful units called tokens. These tokens include keywords, operators, and identifiers. Lexical analyzers such as lex or flex are used to perform this task, ensuring that the code is ready for the next phase. After lexical analysis, we move on to parsing. Here the tokens are arranged in a structured format like a parse tree or an abstract syntax tree or AST. Parsing ensures that the sequence of tokens follows the grammar rules of the language, setting the foundation for further analysis and code generation. Once parsing is completed, we proceed to semantic analysis. This phase checks for logical errors such as type mismatch or improper use of variables. The code is then ready for code generation, where it is transformed into machine or intermediate code. The code generation process turns the structured representation into executable code. Now let's compare compilers and interpreters. A compiler translates the entire source code into machine code at once, generating an executable file. Like languages like C and C++ uses compiler. On the other hand, an interpreter processes the code line by line, executing it immediately. Examples of interpreted languages include Python and Ruby. Compilers are known for their speed. Once the code is compiled, it runs faster than interpreted code because it has been converted to machine code ahead of time. Additionally, compilers can optimize the code for better performance. However, they do require time to compile the source code before execution. On the flip side, compilers have some drawbacks. The main disadvantage is the long compilation time, especially for large code bases. Additionally, compiled code must be recompiled for each platform, limiting probability. Interpreters, by contrast, don't require a separate compilation phase. Code is executed line by line directly from the source. This gives interpreters flexibility and debugging is easier since you can track errors as they occur. However, interpreters generally have slower execution speeds due to the line by line translation. While interpreters offer flexibility, they also have significant downsides. The primary issue is slower execution speed, as the code must be interpreted each time it runs. Moreover, because there's no separate executable, the source code must be present to execute the program. Now let's talk about just-in-time JIT compilation. JIT compilation combines the best of both worlds. The code is compiled during runtime, allowing for optimizations based on how the code is actually being used. Java is a prime example of a language that uses JIT. The code is first compiled into bytecode and then optimized and executed by the Java Virtual Machine or JVM. In practice, different languages implement these strategies in various ways. For example, Java uses JIT compilation, while Python is interpreted but also utilizes bytecode for performance. C++ is typically compiled directly into machine code. Understanding these implementation strategies can help you choose the right language for your needs. Why does all this matter? Language implementation strategies directly affect performance, debugging, and portability. Compiled languages tend to offer faster execution but may be less flexible, while interpreted languages are easier to debug but slower. Understanding these differences can help you choose the best language for your project. To recap, language implementation involves several phases: lexical analysis, parsing, semantic analysis, and code generation. Understanding how compilers and interpreters work helps in choosing the right language for specific tasks. JIT compilation offers a balance of speed and flexibility, and different languages implement these strategies in various ways.